So it's a hopefully very easygoing, non-technical talk/discussion, semi-improvised. So if you have any questions or comments, feel free. I'm going to talk about how we see, again, a bird's eye view of software upgrades in embedded systems, robots especially. So just to set the stage and the quick overview of what happens when you do a software upgrade to a robot. The thing happening is you have the file that you go into to flash on the robot. For example, for now it doesn't really matter where it comes from. It may come from a cloud or a computer connected to a robot over some kind of network or hardware. Let's blot that out for a second and just concentrate on what the robot sees. So it sees a new file, it's a binary file, and they download it to its memory. And then it needs to verify that it's an authentic file, so it gets a kind of cryptographic signature. And if it's successful, it will reboot the new image and start from there. So that's the basic view of how it works. And we, as Invido, as a software security company, and now as a part of jFrog, are concentrating on what can go wrong. So let's think about it. First of all, the actual file, it came from some kind of developer who wrote the source code, right? He did not write the binary file. The binary file is the only thing that robot cares about. And there's a big distance between the two. It got compiled, it came through some kind of network connection. We don't know what happened exactly in the middle. So there's a long way between them. And the binary file itself is opaque. No one knows what's going on inside. If you look at it at a text editor, you won't see much. So it starts to be problematic, and from the point of view of the machine, of the embedded device, the only thing stopping someone from uploading something completely wrong to its memory is the signature. So, sounds problematic. So, did we even flash the right image? How do we know? So, there are two scenarios here. One is, it's not even the image we wanted to flash. It's someone malicious, somehow manipulated the network or connection or hardware and made us replace the file. So in principle, so it's called supply chain attacks, and it's quite going strong now for the good or for bad. So in principle, we should be saved by the signature, right? So we have this cryptographic signature mechanism that calculates in principle a number that will be different for a forged file, and it's very hard, supposedly, to create a file that will give the right number. But does it really work? We'll touch on that. And the more, much wider category of things going wrong is mistakes. Just mistakes by someone. So there are many mistakes. Let's look at some of them. There's a spectrum of complexity of the mistakes someone could make. So starting from the very basic mistake with just uploading the wrong version. Maybe it's just not the right file. Maybe it's the right file of the right software that you wrote, but wrong version of software that was supposed to be bundled with it. Wrong version of the operating system, some kind of infrastructure. It's very common that just someone forgot. Maybe it's a debug configuration. Maybe you left a debug port open. It's also something you will not see in the binary file. And then it gets the tree splits out, and they can get very complicated. Maybe something is misconfigured. Maybe something is missing. Maybe there's a bug. Okay, so it becomes very general. But in principle, all the things, if you could just look into the binary file and see what's inside and analyze it, maybe you could prevent some of those things. Touching on the supply chain attacks. So again, as we said, in principle, have this cryptographic signature. In principle, it should prevent someone else from installing a bad file. If, let's think about it, if actually no one knows the private keys. But if someone knows the private keys, now this works. And if the update mechanism even works, which is also always not always the case, and we'll see that. So both cases are possible, and actually in both cases you would see some signs of something going wrong in the binary image. And I'll show you an example. And for this case as well, our claim is that if you could look into the image and analyze it, you could prevent some of the problems. So what's inside the image and how do we see it? So basically the image contains all there is to know about the software that the robot is going to run. So it has some kind of operating system. Sometimes it's a real-time operating system, so it's bundled together in the same image running in a single file. Sometimes it's not. There are publicly known programs, there are their configurations, and there is some proprietary software. That's the general overview. So what you could possibly learn from it are the versions of the components, which give you the known issues that are already publicly known. And maybe if you knew what the components you have and have it monitored, you could prevent those issues. And there are also artifacts that could be hidden in the software that you would not want there. So specific examples of what you could find there and what you could ask about what's in the image. So what's the Linux kernel version? What kernel options are configured? What's the version of RAUC or update software? What's the version of ROS? Are the serial ports enabled? Is OpenSSH running? Is ROS running from a dedicated user or not? All those are security issues, and you got a file. What do you know about it? Nothing. You know its size. To have a more specific example of bad things happening, this is an example of bad updating mechanisms. So actually, bad things happening in updates are quite common. Especially they are common when the implementation is custom. So first lesson to learn is never implement something you don't have to. But this is an example which actually illustrates two things. First is that there are problems with update mechanisms. It's nothing perfect, and you shouldn't trust it blindly. You should monitor the bugs that appear. And second, that you must know the versions of the software you're using. So this is a bug in RAUC, which is a client for over-the-air updates for embedded Linux. It's quite commonly used. It's established software. It's not something, and we found we found a bug in it, which was only fixed in version 1.5. So if you're using a version below that, you're vulnerable. It's very, very not good. And we'll see in a second why. And this is the CD number if you want to reference it later. So what's going on in this bug? This is the happy flow. This is how it's supposed to work. So user provides a file. This green binary file is good, and tells the embedded system, the robot, to download it and start flashing. So it will first download the file, then it will verify that the cryptographic signature matches, and then it will flash the system partition if it matches. So that's the good flow. That's how it's supposed to work. We started with a white file on the system partition, and ended up with the green file, which was also what was supposed to happen. So if an attacker tries to upload a file that's not good, it will not pass its check, and it will not be flashed, which is great. Now comes the bug. If we ask the robot to flash the green file, and then after it has been already checked, ask it to flash the red file, what's going to happen is very simple. The robot will say, okay, now we'll download that one, and we'll replace the green file with the red file after the green file has already been checked. And they will flash it in the red file. Meaning that this whole protection mechanism doesn't do anything, basically, and you can flash whatever you want. So in order to prevent that from happening in your firmware, you must know what version of RAUC you're using. And it's, of course, very hard to do that after you've already compiled it. And another spectrum of issues are the crypto issues. So the common ones are outdated standards, proprietary implementations of crypto, which are very bad for the same reason, and also much simpler issues of just having private keys in your firmware, or having private keys that are corresponding, public keys corresponding to private keys which are known to be exposed. So you ask yourself who will do that. It's really everyone. So very, very big and very established companies forget private keys in their firmware, which basically means that anyone can forge firmware for that hardware. Anyone who has those private keys can make firmware update file that will be flashed correctly because they are developing now. And very big companies forget either in the firmware private keys or even in the GitHub. So that's something that happens. And again, after you have the update image, you have little way to know what exactly you want there. So that's our perspective, and our perspective is that we need to have this technology to be able to look into binary images and be able to run checks on them. And that's what we're working on at Vido, and now it's a part of jFrog. Our take is that the security of the process is not something you take for granted, and it needs to be continuously monitored, and you need carefully design CI/CD and distribution. You need to have visibility into the binaries you're distributing, and you need to monitor for crucial weak spots, which are cryptography and the implementation mechanisms. And you need to avoid the proprietary code and the code is not, take care to monitor the versions of the code that's not proprietary. This is of course just one world of things that are related to updates. There are many bad things that can happen, and it's just part of the examples of things that are at least related to the sector. And I want Fred and Asaf to talk about the mission.
Yeah, one thing that Ilya didn't say is that the CVE of ROC update is coming from out of his brain. So thank you for that. Yeah, so one of the main mission of and why jFrog and Vido are working together is basically to bring all this great knowledge of embedded software and watching embedded Linux and all over the kind of OSs to all of you into tools and environment and systems, so that basically you don't have to find great guys like Ilya to look at your binary everywhere to automate it. So Asaf created this great environment, and today, as part of what we do, which is so securing the supply chain management, providing the tools to help you secure the supply chain management, and making sure that nobody gets in the middle at every step, from everything that you get and all your third-party components all the way to the end. And a lot of our big customers are using the platform to do a global update, like Bosch or NVIDIA or all these kind of things, to extremely large amount of systems. And so maybe Asaf can talk a little bit about ERA also and some more, but we have a lot more. Asaf.
Okay, hi guys. So of course I agree with everything Fred said, but maybe a couple of points that are of interest. Now the reason we started Vido, it's a very embedded oriented company, and we wanted to, we came from a background of developing and securing these kinds of devices, and we wanted to have a platform that does a lot of the hard work for us, knowing full well that most engineers either don't care or don't have the know-how or don't have the time and resources to look into all of this stuff. Now you use Route, that's what everybody uses, or other update software. You assume that it's why do I need to secure it, configure it, look into the versions? I assume that it's fine. Well, in many cases it's not, and it's very, again, time consuming to verify that it isn't. So we try to automate that by doing this most simplest thing and asking for the binary or the firmware, so you don't have to do anything, no very complex integrations. You just supply the firmware like you would, and you don't need to expose anyone to your source code or secrets. Now, the other reason to look into the binary, and that's part of why this collaboration, why this partnership, this acquisition has taken place, is because that's how attackers look into it. Attackers look at the firmware, they get the device, they dump the firmware, or they just download it from the update, or they do a man in the middle, and they grab it while your phone is updating the device. And that's a very good way to look at the firmware, like the ones who try to attack it. And now, what Ilya just showed with examples on Netgear and stuff like that. That's real stuff happening. It's very simple now. Now today we have like bug bounties and CVE hunters that just want fame. They just download firmware, do a very simple scan. Part of the things that we do at Vido, they're just taking some ideas and they just scan for private keys. When you find the private keys, they go and they do this large publicity on Netgear. Netgear is insecure, Cisco is insecure. It's becoming more and more common, and you just want to at least not have the lowest hanging fruits in your firmware. So that's part of the reason why automation is very strong about it. Now to the second point that Fred mentioned, another area that we are seeing is with devices becoming more and more common and with updates not always being very simple to get, is having some sort of protection layer inside the firmware. We call it ERA, it's embedded runtime agent. It's automatically generated from the firmware. It's a very interesting aspect that most common devices in firmware and embedded Linux are not built hardened, or when they were built, no one knew about some sorts of attacks. So you want to have this additional embedded layer that always does the protection, and that's part of the distribution network that we are building, where you have the firmware distributed and with security inside of it automatically. So that's part of this collaboration. Yeah, anything you wanted me to add on that?
Right.
Yeah, cool.
So yeah, hopefully we're going to secure more of all what you're doing, and the goal, the final goal of everything is to make sure that you are not afraid of doing updates. At the end of the day, updating your robot and updating everything, it's a huge power compared to anything in your competition. If you start by saying updates are a pain in the ass and I'm trying to build something that I don't want to update, you're already going wrong, okay? So the goal for everything that we are doing is to give you the confidence that you can keep updating and keep creating better robots over the time and capturing what's out there. Good luck.